This is homework set 26. Question 1. We've got two functions here. We've got f of x. We've got a function f, linear function, and we've got a g, a quadratic function. And what we're going to do is make the following evaluations. So we've got 6 parts. Let's go down here to part A. I'll do it right down here. So in part A, we want to compute f of 4. So what I'm going to do is I'm going to locate the function named f. Here it is right here. And you can see that that x right there has been replaced with a 4. So look at your function, f, replace all the x's with a 4. So I'm going to have this. I'm going to have 3 times 4 plus 2. So I get 12 plus 2. I get 14. All right, so I'm going to put a 14 in here. What it says to me is, it says this. When the input is 4, the output, right, that whole collection of symbols is the output. When the input is 4, the output is 14. So you put in a 4, you get out a 14. Now, part B. Part B, we want f of negative 2. So I want f of negative 2. Okay, let's see. F of negative 2. So I'm going to locate the function f, and where is it? We just used it. All right, here's f. Now you can see that that x has been replaced with negative 2. So replace all the x's with negative 2. So I'll replace that x with a negative 2, and we will get 3 times negative 2 plus 2. So how about negative 6 plus 2? We'll get negative 4, right? So I'll put a negative 4 in here. And what it tells me is this. When the input is negative 2, the output is negative 4. So put in a negative 2, get out a negative 4. Now part C. In part C, we now want g of negative 2. So locate the function named g. Now g is this one right here. It's this quadratic, x squared plus 3x minus 3. And you can see that that x has been replaced with negative 2. So look at your expression, replace all the x's with negative 2. So I'll get negative 2 squared plus 3 times negative 2 minus 3. Let's write it out. I'll get quantity negative 2 squared plus 3 times negative 2 minus 3. So I'll get 4 minus 6 minus 3. 4 minus 6 is negative 2 minus 3. That's negative 5. So let's claim now that this is, I'm up here at the top, this is negative 5. And I just want to note something here. This says right here, this says to replace x with negative 2. Now if I come up here and I replace that x with negative 2, I get this. I get negative 2 squared. I do not get negative 2 squared. This is negative 4. This is 4. All right, so just be careful. Now, D. D is, all right, this is D. G of positive 2. All right, so locate G. All right, we know what G is. Replace all the x's with 2. So I'm looking now at this function up here at the top. I'm looking at this one. I'm going to replace all the x's with 2. All right, so let's do that. I'll get 2 squared plus 3 times 2 minus 3. So I'll get 4 plus 6 minus 3. That's 10 minus 3. That's a 7. All right, so let's claim that this is a 7. Now, part E, or I'll do it up here at the top. E is this. In the function called f, put in an a plus 1. So locate the function named f. That's this one right here. And use that one. All right, now I can see that that x has been replaced with a plus 1. So replace all the x's with a plus 1. So I'll get 3 times a plus 1 and then plus 2. Right, it's like, you can kind of see this, right? It's, let me see if I can write that here. It's kind of like this. Oh, that doesn't work. Okay, let's try this one. How about f of x equals 3x plus 2. There's the x. Okay, that's what I'm doing. Now, multiply it out. So we'll get 3a plus 3 plus 2, or how about 3a plus 5? And over here in the answers section, I will put the 3a plus 5. Now, part F. What we want is g of a plus 1. So locate g. All right, g is this quadratic up here. And you can see that that x has been replaced with a plus 1. So come up here and replace all the x's with a plus 1. I'll get a plus 1 squared plus 3 times a plus 1 minus 3. Let's write it out. I'll get quantity a plus 1 squared plus 3 a plus 1 minus 3. All right, so first up, square this binomial, right? Square that binomial. Talk your way through the pattern. Square the first, a squared. Multiply these two together and double it. A times 1 is a. You double it, you get 2a. Square the last. 1 squared is 1. Multiply through. Plus 3a plus 3 minus 3. All right, now I got an a squared. I've got 2a plus 3a is 5a. And then I've got, well, those 3's will cancel off, so I just have a plus 1 there. So over here, let's write, I'm over here on the left, I'm going to write a squared plus 5a plus 1. Well, that was a lot of work, and we just finished question 1. This number 2 looks like a monster, but it turns out we don't have to compute anything. Here's what we wanted to. I've got two functions here, f, which is this set, and g, which is this set. So instead of the functions given by an expression, they're given by a set of ordered pairs. Now, part A, what is f of 4? If you put in a 4, well, locate the f function. Here's f. Here's f. What do you get if you put in a 4? There's the 4. You put in a 4. Remember, the first component is the input. Second component is the output. So if you put in a 4, you get back a 0. Now, what's part B? In part B, you're looking at the g function. All right, g is over here. And what are you putting in? We're going to put in a 3. So locate the g function, locate a 3. There's a 3. So what do you get back out? You get back out a negative 2. No computations. G of 2/3, all right? So if you put 2/3 into g, here's g. Do you see 2/3? Right there. So if you put in 2/3, you get out a 0. And this one, f, what's f of 1? So locate the f function right over here and put in a 1. There's the 1. You get out 1/3. Okay, see if I can get it to work. Now, the next one is g of negative 2. So locate g. All right, you locate g, and you're going to find a negative 2 for the first component. All right, not that negative 2. That's an output. I want the input. The input's always the first component. Put in a negative 2. I get out a negative 1. All right, and then finally, what is f of pi? All right, so locate f right up here and locate the first component being pi. Here it is right here. You put in a pi, you get out a negative 3. That's it. Here in question 3, we're going to evaluate this function here, this quadratic, x squared plus 1, at different values. All right, so let's do part A. Let's look at part A here. Part A, what we want to compute is f of a plus 3. All right, so first of all, let's get this part f of a. Now what that says to do, it says to locate the function named f. That's right up here. We have only one function. And replace all the x's with a's. Now this x up here in the original function, that's a placeholder. It's a placeholder for whatever you put in. Right? So what we're putting in now is just an a. So replace all the x's over here with a. We will get that this is a squared plus 1. Right? This is a f of a, and then you still have that plus 3. Right? That part right there, that's the f of a. Now, a squared plus 1, a squared plus 4. All right, so in our field up here, I'm going to say this is equal to a squared plus 4. Now, in part B, we're going to compute f of a plus 3. All right, so just what we're going to do is locate the f function. It's the only one we have. It's right here. And that x is a placeholder. It's holding a place right now for a plus 3. So here's what this says. F of an input. is equal to, you square the input, add 1. Now the input is a plus 3. So if you replace, put that a plus 3 into that x, we are going to get a plus 3, square it, add 1. Okay, this is the f right here. That's the f of a plus 3. And then I'm going to add 1. So let's do this part right here. You'll get a squared, right, square the first, multiply the two together, 3a double it, 6a, square the last, plus 9. Then you still have that plus 1, right? Now this plus 1 is that plus 1 right there. This part right here, a squared plus 6a plus 9, that is the x squared part of it. Okay, I can add these two together here. So we're going to get a squared plus 6a plus 10. So let's put that into our field here. A squared plus 6a plus 10. And now in part C, we're going to compute f of g plus c. All right, so locate the f function. That's the only one we have still. And I'm going to replace that x with our new input, g plus c. So replace all the x's with g plus c. So if I replace that x with g plus c, I have to replace that x with g plus c. So I'm going to get g plus c squared and then plus 1, right? I get g plus c squared plus 1. So let's square this. So you square the first, g squared. You multiply these two together, gc, but you double it. So if you have gc and you double it, you get 2 of those gc's. And then you square the last, plus c squared, and you still have that 1. So let's put that into our field. We're going to claim this is g squared plus 2gc plus c squared plus 1. That's the end of the first questions on homework set 26. And that brings to an end our discussion on the first 3 questions in homework set 26.